Hello guys. So in continuation with the photoelectric effect, as we discussed, the Einstein's photoelectric equation has many uses. So one of the use, if there are two different radiations, and if we have to calculate the threshold frequency, then we can use. So this is one of the problem. So there is one light which has a frequency 2 into 10 raised to 16 hertz, and obviously it has a certain energy is associated with it. That amount of energy is absorbed by the electron. Another radiation which has a frequency 1 into 10 raised to 16 hertz, and that also absorbed by same element's electron. So it is observed that the energy associated with the first frequency is twice the energy associated with the second frequency. So what will be the threshold frequency? So let us consider this problem. A light ray energy or the radiation which has a frequency 2 into 10 raised to 16 hertz, and the energy associated with this is E1. Same electron is absorbing frequency radiations mu2, and its value is 1 into 10 raised to 16 hertz. The energy associated with it is E2. The relation between these two energy is the energy associated because of frequency 1 is twice the energy associated due to frequency 2. So now we have to calculate threshold frequency. So how can we calculate that? So according to the Einstein's photoelectric equation, h nu is equal to h nu 0 plus kinetic energy. So this is h nu 0, threshold frequency. So let us consider this is h nu 1. Now in both the cases the kinetic energy is same. Rather here we have a relation that energy is nothing but the kinetic energy. So let us consider this is kinetic energy 1. So what can I say here? H nu 1 minus h nu 0 is equal to E1. Similarly, I will write h nu 2 minus h nu 0 is equal to E2. Now what is the relation between this? E1 by E2 is equal to 2. So I can say h nu 1 minus h nu 0 divided by h nu 2 minus h nu 0 is equal to, we have now E1 by E2, that is 1 by 2. So if we substitute the values now, we can easily calculate the value of nu 0. So we have the value, so 2 into 10 raised to 16 minus nu 0 divided by 1 into 10 raised to 16, simplify it and you will get the value of nu 0. Very simple problem. But sometime, now here I put directly data, but when we are dealing with a word problem, sometime they may confuse you by adding some certain other parameters. Instead of the simple calculation, they may tell you to calculate, they will give you the wavelength, and from that wavelength we may need to calculate threshold frequency. So the procedure wise we have to use this concept only, and the procedure methodology we have to follow this way. So this is one kind of a problem. Now when we are dealing with these radiations, as I already told you, here we are dealing with current generated by photons. So photoelectric effect. Now if we apply potential, then what will happen? Because of the external potential, because of the external energy, which electrical energy we are applying, the velocity of the electron is now drifted, it goes on decreasing. At a particular potential, that electron is not ejected out, means it has zero velocity, it has zero kinetic energy. That potential is called as stopping potential. So rather, in that case we can say that the potential which we applied, and due to this the electrical energy which we are supplying must be equal to the kinetic energy of the electron, means half mv square is equal to E into Vs. This V stand for velocity of electron, velocity of ejected electron, and this Vs stand for stopping potential. Where E is charge on the electron, magnitude we have to take, that is 1.6 into 10 raised to minus 19 coulomb, and mass of the electron. Now this plays a very important role whenever we are dealing with photoelectric effect, photoelectric current. So again, this is a kind of a physics problem. So very simple problem, simple substitution we have to see in this next problem. Calculate stopping potential if the velocity of electron is 2.9 into 10 raised to 8 meter per second. So velocity of ejected electron. So directly we have to substitute the values. You will get the stopping potential, that is Vs. So here Vs is equal to half into mass of electron 9.1 into 10 raised to minus 31 kilogram multiplied by velocity 2.9 into 10 raised to 8 whole square, okay, divided by 1.6 into 10 raised to minus 19 coulombs. So whatever the answer we are getting, that will be volts. So this much volts we have to supply, applied across, so that there will be no photoelectric effect, means no ejection of electron. Okay. Now, upon understanding these concepts, so what we have studied till now, we have studied photoelectric effect, quantum mechanics, and actually we change our track from electron to the properties of electrons. Now, why we need to understand the properties of electron? See, when I am saying ejection of electron, from where to where, that we need to understand. When I am saying a substance has a particular color, when there is an emission spectroscopy, when there is an absorption spectroscopy, then these spectra are arising because of the excitation of electron from one energy level to another energy level. So from where these energy levels are coming? From the atom. So the electrons are placed in different energy levels. This concept gives a new dimension to the structure of atom, and that new dimension was added by NEET Board. So we will be studying Bohr's theory of atom. Now actually for our level, rather than JEE Advanced and JEE Main, the problem based on Bohr's theory are very, very important. Now what is the success of Bohr's theory? It could able to explain the structure of hydrogen atom or the elements which has one electron, and that is a big success of this Bohr's theory. Obviously it has a certain disadvantages, but it has given a new dimension to see the position of electrons. At the same time, the drawback occurred during the Rutherford's atomic theory, that electrons are revolving around the nucleus can lose electron energy and can fall into the nucleus. But Bohr has suggested one concept, and on that basis now electrons cannot lose energy, and therefore they are never fall into the nucleus. That means there will be a stable structure of atom. So all this part we have to discuss, that we'll discuss in the next session, along with some problems, some derivations and some few concepts. Thank you.